Have you ever wondered how websites keep track of the changes in real time? Think of infinite scrolls, live comment session, or even dynamic dashboards where elements appear and disappear on the fly. In such cases, do you rely on event listener? What if I told you there was even a better way? Hi, I'm Rahul Bharti, a senior software engineer at EPAM with over 6 years of experience in building and maintaining a scalable web applications. Today, I'm diving into one of the JavaScript lesser known yet incredibly powerful tool, which is Mutation Observer. Whether you are building a dynamic SPA, tracking DOM updates, or just tired of attaching multiple event listener, this API is a game changer. Stick around because not only we will cover the basic, but also I'll show you a practical use case that will elevate you how you handle dynamic changes on your web apps, and by the end of this video, you'll have a tool to simplify your code and impress your team with modern techniques. If you enjoy content like this and want to learn more about web development and practical software engineering tips, make sure to hit subscribe and turn on notifications. I post new videos every week to help you elevate your skill and stay ahead in the ever-changing, evolving tech world. Mutation Observer is a JavaScript API that allows you to monitor changes to the DOM, like adding or removing elements, modifying attributes, or updating text. Instead of attaching multiple event listeners, you can use a single observer to handle these changes in a centralized and more efficient way. But here's where it gets interesting. Mutation Observer doesn't just stop listening to the events, it observes. It can monitor entire section of your DOM for a wide range of changes simultaneously, something event listener just can't do as elegantly. Okay, here's a very simple example. So we have a HTML page which has a single text area and a single button. So we have initial content and a button. So what happens at this button is that when we click on this button, we add a new child. Let's take a look at the JavaScript. So it has very simple thing. First, we create a target node that we want to observe. We have a observer callback. So basically, this is the function that will get executed if there is some changes into it. Then we create an observer by creating a new instance of an observer mutation observer class, and we provide it with the callback. We have a config. We only need to check for child list change, so we are only providing child list. There are other options that we will see in the advanced version of it. And then we just set it to observe the target node. Now, this is where our observer mutation ends. Let's add a simple function to add a new child, which is we create a paragraph tag, we add a content as a new child element, and we append it to the target node. So here, initial content, let's take a look at that. So when I click on add new child, I see that child node has been added or removed. On each click, we will keep on adding or removing child. So if we take a look at that, what is happening here is that in this observer mutation, when the child list, the mutation type of child list is there, we are just throwing this particular console log, which is what we see here. Now, this is good and all. Let's move on to the little bit more advanced stuff. Let's take a look at an even more complex example. So we have a single page which lists all the products. We have two products listed out already, and then we have a div which contains two buttons, which is add product and update product. This is how it looks like. We have few products and we have total number of products. So when I click on add product, I see this new alert opening up. So here, what if I told you that the content, this content, and also that alert is being shown through a mutation observer? It doesn't depend upon this particular button event. Let's take a look at the JS code. So we have the product list, notification container, and product count. So for now, these two elements are being created on the fly. Then we provided with the ID, some class name, and some basic setup. We are just adding a new product after the end of the product list. And for each product, we are setting up the ID, class name, and text content so that this will always be there. So this shows us here total number of products and the total number of product count. Now, our mutation observer is a little bit different from what we had before. Our mutation callback consists of, again, mutation list and observer, but now we have mutation for two things. First is the child list and second is attribute. So if that's a change with child list, we want to add a message which says a new product was added or a new product was removed. And then we run this function which is show notification with message. And then we update the product count. And the same thing happens when there is an attribute change. So let's take a look at show notification method. Show notification method is very simple. It just takes send message, sets a message and displays the element style as block. And then we do a set timeout to this to hide the particular notification. And update product is even simpler. We just add a few things. We just select a product and we just change the and then we just add the length of the product list child. Update product. In update product, we again select a product class. First product, we select the first product and we just update the dataset ID from being one by just incrementing it. We are not doing anything very fancy, but this is a little bit more complex than what we had. Now, in this simple example, we were only checking for child list being true. But in this config, we are checking for child list attribute changes or even a subtree changes. So what does that mean? That anything that happens into this particular DOM needs to be reported back to the mutation observer that will observe and run the functions of updating the product count and showing messages to us. So let's do a quick example. Once again, we add a product 5, total number updated, and we have a new product which was added. And we can keep on doing that. So if we check this attribute being changed, we can just go to elements. Let me just inspect this. And if we see we have dataset ID as 4. If I add more, the dataset ID increases even higher. So this is how the mutation observer works. Now here comes the question. Is mutation observer better than the event listener? For static user triggered actions like button clicks, event listeners are fine. But for the more dynamic real-time applications where DOM changes are done very more frequently, mutation observer can be a really game changer. It reduces your code complexity, improves your scalability, and also centralizes the observation of your DOM changes in a single place. In the scenario like SPAs or live feeds or even dynamic contents, the listeners can feel outdated very easily. Mutation Observer is more than just an API. It's a powerful tool for building a modern dynamic web applications. Whether it's a simple or more complex real-time updates, it can make your code cleaner and more efficient. If this video helped you to understand Mutation Observer, don't forget to like, subscribe, and share your thoughts in the comments. And check out the blog linked below to detailed examples and explanation. See you in the next video.